Hello and welcome. Sorry about the little delay. We've had some smart contract problems. I'll talk about Ethereum 2.0, the upcoming new version of Ethereum. Apparently there has to be one Ethereum 2.0 talk on every conference, and this year, this time it's mine. It's my turn to have it here. So I'll briefly cover what's going on, when is it going to happen, how is it going to happen, and how it will affect anybody who's interested in those effects. Usually there are either very many questions or not at all for this topic, so I'll aim to go through everything quickly and encourage questions so that anybody can ask whatever they're interested in, because we really are closing in on 2.0 and we should be fully ready in 2020, but earlier phases are going to be done much sooner. So I really encourage you to, there are no stupid questions. Please don't feel ashamed about asking anything at all. And I can't promise to know the answer to everything, because my full-time job is to cover this stuff and to work on it, and I still am not completely up to date with all the aspects, so I'll do my best. So my name is Bruno. I'm affiliated with a bunch of projects, most recently, or mainly, Nimbus at Status, and Nimbus is a Ethereum 2.0 client, so an upcoming client for the next generation of Ethereum. If you're interested in any of these other projects, just look them up and we can talk more. If you catch me in the hall, I'll tell you about it if you're interested. So, and if you're not familiar with Status, Status is an organization which had an ICO in, I think, 2016, and they are building a decentralized chat application, messaging application for Ethereum based on Whisper. And the aim of that application is to provide communication to anybody in the world who wants it. But communication can be exchange of any type of message. And the message can be financial or chat or content-based, so visiting a website that might otherwise be forbidden elsewhere, so via IPFS and so on. So it's a decentralized messenger that's working on becoming as lightweight as possible, so it can run on old devices and still give you anonymous but censorship-resistant global communication. And this is kind of part of the goal we're working on at Nimbus, because Nimbus is the Ethereum 2.0 client that's written in the NIM language, which compiles to C. So it's extremely fast and very research friendly. So it'll work on really, really, really weak devices. If you want to run a validator in proof of stake in Ethereum 2.0 on like a smart oven, you can do that with Nimbus. So we're aiming to cover the rest of the world who aren't participating in the network right now. We're aiming to cover that with Nimbus. So Ethereum 1.0, as we all know, has a problem with throughput, so very, very low transaction count. The state size grows a lot. If you want, if some of you were at my desk outside, I have some full Ethereum nodes running on small computers, and that's not very demanding. But it can be prohibitive to third world and so on, because they don't really have the bandwidth or the 300 DAI needed to buy those devices. The state size right now for Geth, for the main, one of the two main Ethereum clients right now, when it's fully synced, is 180 gigabytes, which isn't that much, and it's definitely nowhere near 2.2 terabytes, as some people claim it is. But it is still quite prohibitive, especially if you consider that the state size is constantly growing, so that can be a problem in the future. We're all constantly saving and validating everybody's data, and that's obviously not scalable. So if I'm trading my CryptoKitties, I shouldn't bother every bank that's using Ethereum, or every company, or every project to also validate my transactions. So this is something that we're actively working on. We're also familiar with the CryptoKitties disaster, where too many people try to swarm on one single dApp at one time and slow the network down to a halt, because all the transactions were going to CryptoKitties smart contracts and no other transactions could go through. So fees skyrocketed and everything kind of ground to a halt. So that was kind of the best stress test that a network can have, because it wasn't an attack, there's a benevolent attack where we realized, okay, we have a problem and we have to work harder at solving it, but no one actually attacked us outright. So that was pretty great. And the problem is that Ethereum 1.0 is used by a lot of projects in a completely wrong way. So they're trying to replace their database with it, and they're trying to combine supply chain and blockchain or AI and blockchain, and all of that is nonsense. And all of that will never work on chain. So now, whether they're in delusion or outright scammers, I don't know and I don't care, but these are wrong use cases and they're harming Ethereum more than they're helping it. We don't need that kind of adoption. So the adoption we need is people who can understand the difference between an essential transaction and one that can be processed with slightly less hash power. There's also the issue of hash power, which is proof of work, which wastes a lot of electricity and is actually one of the primary reasons for centralization of blockchains today, because the tendency for miners to group together in certain areas that have both cheap electricity and then enable them to have low latency between the nodes, between their servers, is making it so that only certain spots on our planet are doing the mining and the validation. And this is obviously very dangerous, because if the government where they are hosted decides to pull the plug, it's not easy to move a whole data center over. Plus, it's super expensive. In terms of proof of work today, a civilian can't hope to join the network unless they have a lot of money to burn. So the argument that the rich get richer in a proof of stake system is more so true in a proof of work system, because you can only join the system if you're filthy rich and join it in a profitable way. You can join it in a non-profitable way very easily, but if you want to make a profit mining, you have to be filthy rich already, which is like a disaster centralization-wise. So there's a kind of a mid-tier upgrade level, Ethereum 1x, which is focusing on upgrading the current proof of work Ethereum so that it's easier to use until we have the proof of stake Ethereum. And one of those aspects is rent, state rent, where like if I send a simple junk transaction, like for example, we're going to have a token hunt later tonight where people are going to run around town and look for QR codes, and they'll be collecting NFT keys, so non-fungible token keys, with which they can then unlock some chests and claim rewards. All of these transactions will be happening on the mainnet. Right now, because the network isn't that congested, that's fine. But if everybody starts using Ethereum, like we hope everybody will, that'll be a pretty stupid thing to run on mainnet. It's a fairly trivial app, and it really shouldn't be validated by all of those people. So it's just a proof of concept that definitely has no place on an Ethereum mainnet. What's more, every claim of a token that those people will make will be registered on the blockchain forever for everybody who's running a node. So I have contributed not a few bytes to one node, which now knows that somebody picked up that key. I have contributed megabytes to the blockchain because that data is replicated across all the thousands of nodes that we are running. And for what? For absolutely no reason other than a temporary application for a conference. So the rent proposal is here to basically make you overpay for a contract's storage and maintain it like a hosting plan. If the balance expires, your contract's data will be kicked out of the network, but the hash will be retained. So what does that mean? That means that if you want to get your data back, you have to be in touch with a node that's keeping a full archive of the blockchain on its own without incentive, and then you'll probably have to pay them to rerun that data for you and restore that data on the same address where your contract was. And that's what the hash is for, so that it finds, okay, yeah, I have this data that this hash matches, okay, let's restore it. This will not only cost you money to access the data, but it will also cost you money as much as you needed to pay rent from the moment your contract got evicted to the moment it's restored. You will have to back pay all the rent. And so this is in place to encourage prioritization of transactions. So you have to think really hard about which transactions you want to include in the blockchain. And it's to encourage monitoring of your contracts so that you can top up their hosting balance as required. And if you no longer need them, you just let them expire. And that way, all of those contracts that we had at the beginning of Ethereum, where people spent hundreds of Ether to deploy demo contracts and hello world contracts because there was no proper testnet and because it was the default option in Mist or whatever wallet. All of those hello worlds we are still validating. And with a rent proposal, that's going to be kicked out of the blockchain, and no one's going to miss that. And we're going to have a much easier time running nodes because they're going to be much more lightweight. That ties into pruning and storage optimization. So we're going to be configuring and building these clients that are working today to prune old data. For example, the new version of Geth, like 1.9.0, is kicking out 70% of the blockchain data into a hard drive. So you no longer need a solid state drive for the entire blockchain if you want to think a full node. Right now, the nodes I'm running outside have a 0.5 terabyte SSD drive, which isn't that expensive, all things considered. It's like €100. But with this upgrade, you can have basically a 50 gigabyte SSD, and it'll work just fine because the rest of the data is going to be on a hard drive, on a regular old hard drive, because it's not needed by the part that's running on the SSD. eWASM is a runtime that we hope will replace the EVM. So the EVM is kind of is pretty cool, but it's super inefficient, and it was more like an experiment that turned out to be working rather well. But it could be much more efficient, much cheaper to run, and much cheaper to validate. So again, the input-output and the CPU requirements of the nodes would get reduced drastically, and it would be cheaper to actually execute meaningful stuff on the blockchain. So the gas cost would go down. So those are the upgrades for 1.0. But then we have the 2.0 Serenity upgrade, which Vitalik at the last DEF CON asked everybody to call Serenity, not Shasper, because people used to call it Shasper because it's merging Casper and sharding. So rather than call it that, we call it Serenity. And Ethereum 2.0 is going to be a completely new blockchain. So from scratch, from zero. It's not going to be an upgrade to Ethereum 1.0. It's going to be a completely new separate blockchain. You might as well call it my chain, whatever. It's just that the same teams are building it, plus some more teams. It's coming out in full somewhere around mid-2020. That's the aim right now, and it's looking like we're going to hit it. So there have been no major hiccups. It's going to be proof of stake instead of proof of work. So you will need 32 Ether to become a validator. And running a validator will require you to run attestations. So you will collect all the proposals from all the other validators, make sure that they are correct, and report back. And if a lot of validators agree that one of those validators or a few of those validators are doing the wrong thing, then this stake, the 32 Ether that you've committed into the blockchain, is going to get slashed. It's going to get reduced. Once you've been reduced enough from 32 to 16 Ether, I think it's 16 latest in the spec, you're going to get kicked out of the validator pool. So you'll permanently lose 16 Ether, and you will be able to rejoin once you have 32 again. But there's a lot of factors that can contribute to you losing your stake. You can be offline for more than 2/3 of a time, and you will start to slowly lose your stake. If your offline time continues, then it's going to grow quadratically. So you're going to start off by losing very small amounts, and then if you stay offline, you're going to lose a lot very suddenly. So it's going to hockey stick. So a validator needs to be sure that it will be able to serve the requests that are expected of it regularly. Not 100% uptime, but more than 2/3 in any case. Another feature here is that when you're validating a network, you're going to have a lot of people validating. It's not going to be like a miner, where in mining, a lot of people are competing to solve the same hashing riddle, and then whoever gets it first gets the reward, and everybody else spent a lot of electricity. In proof of stake, there's no electricity spending in terms of guessing random numbers, but somebody has to be picked to be the representative validator whose suggestions will get accepted and propagated to everybody else for verification. And then if those suggestions are accepted, that validator will get a reward from the blockchain, just like the miner does. In order to make this fair, we need a reliably random system, because computers can't generate random numbers properly. It's very difficult to get the system to randomly select a validator and be fair in this. So what is going to happen in Ethereum 2.0 is, who's familiar with RANDAO? No one. Okay. So RANDAO is a system where it's like a set of smart contracts where some clever people came up with a way to get a random number from Ethereum. Right now, a lot of apps have depended on, like when blocks are processed in Ethereum, they get this timestamp, and they get this block hash. And from that, because nobody knows what that hash is actually going to be, from that you can get a reasonably random number. However, if the stake involved in that random number is bigger than the cost to actually attack the network at that point, so for example, a huge lottery is being held, and your influence on the randomness of that lottery is worth more than the ability to earn the block reward for fairly mining the blocks, then you have incentive to manipulate the transactions in that block to an extent where it will allow you to change the lottery winnings. And that's possible. That's a common problem in casinos right now. So that's why you only have dice games or coin games or silly stuff like that in casinos in Ethereum, because nobody's handling large amounts of ether with on-chain randomness. So to get proper randomness in Ethereum 2.0, the validators will all commit to a certain number. So they'll like imagine a number in their heads. Then they'll hash it so that it cannot be decrypted. So it's going to be hashed, which means it can't be reversed. It's going to be just hashed with a seed that turns it into a long string of letters and numbers. And then all of those hashes will be bound together, and they will form the basis of a new random number. To reveal their number, which was selected, the validators will have to reveal one layer of hashing at a time. So, for example, if I hash the number 5, then I'm going to get a random string of letters and numbers. If I hash that again, I'm going to get another string of letters and numbers, and so on. So this chain reaction of hashing is going to serve as a means to get random numbers at the end of this chain. So all of these validators will collaborate in picking a random number together. It's like imagine if all of us, each of us, picked a random number, and then we decided that the winning number is the square root of the sum of all of our numbers. There's no way to know this, which number it's going to be. And it's going to be a reasonably random number. But if we are revealing our numbers in order, the last person to reveal has this one chance of slightly influencing the randomness. Because when all the numbers except the last one have been revealed, he can see, okay, if I reveal mine, that number is going to be this. But if I don't, that number stays at this. And then he can choose to stay silent at the end. He can choose not to reveal his number. He can pretend to be offline. And that's how he can slightly influence the randomness, which works to his advantage if the reward for faking this is very large. And to get around this, a separate thing is being introduced in Ethereum 2.0, which is called the VDF, verifiable delay function, where all of these reveals are happening, but then a further delay is added onto the end of revealing, which is kind of complex, but anyway, everybody reveals their number, and the system can't go on until everybody reveals their number. And this is how random numbers will happen. They will have a delay, so once the new chain starts, 1 hour from that, a random number will be produced. From that moment onward, every 6.5 minutes, every 6.4 minutes, a new random number will be produced, and those are the step delays that we've introduced there. It's hard to explain, but just believe me that it's a reasonably random number implementation in Ethereum 2.0. So validators we've already covered. There's also going to be beacon nodes. So you can think of today's miners are the validators, and the beacon nodes are going to be like full nodes that I'm running outside. So a validator can be super lightweight. It can run on any weak device, but it needs data from a beacon node. The beacon node is a client, a software program on the new blockchain, which is relaying information to the validators. The validators read this information, say, okay, I think a new block should be like this and this, and he sends it back to the beacon node, which then sends it back to the validators. This benefits us in the way that we can run validators on very weak devices, and only average computers, like for example a desktop computer, can run a beacon node. To join the system, you're going to be able to stake and be a validator on a very weak home device. On your home computer, you can run up to 5 or 10 validators easily, which right now is for 10 validators, you need 320 Ether. So there's no worry about not being able to join the new chain. In a hardware perspective, you can very easily contribute and earn some staking rewards. Sharding is planned in the final stage, at least cross-shard transactions. So sharding is the concept of having tiny little baby chains of Ethereum. Each of those is processing its own set of transactions. So we are now doing what I talked about, like when we need to split up the transaction pools into different levels. One shard is going to be for something, one shard is going to be for something else, and so on. And then in order to communicate across these shards, it's going to be like many little blockchains communicating through this common beacon chain. You can imagine it like a backbone with ribs sticking out. And then all of them communicate through this beacon chain and exchange data. So if you need to send money from one shard to the other, it's going to send money. It's going to generate a transaction on one shard, submit the proof of that transaction to the beacon chain, and the beacon chain is going to send that proof to the end shard, and then the end shard is going to know, okay, I got some money. This is going to slow down transactions across shards. And the actual cross-shard transactions are probably going to have to happen on layer 2, so another layer built on top of Ethereum. But what we get with sharding and with proof of stake is the fact that we get a maybe 10,000 times increase in throughput of transactions, because we have divided the network in a way that lets individual shards process their transactions as much as they want, and we've sped things up with the EWASM replacement of EVM and with proof of stake, which doesn't require hashing and guessing of numbers, that we can process everything much, much faster. And so in all this, what happens to the proof of work chain, which contains a lot of data right now and a lot of people are using? It's going to also be turned probably into a shard, but it's going to be a legacy shard. So when time comes to move completely to 2.0, the 1.0 chain is going to be turned into something that resembles a read-only contract. So it's going to be like a read-only hard drive that's going to be permanently attached to the new blockchain. And you will be able to read the data from the proof of work blockchain forever, but you won't be able to modify it anymore. Anybody who's running on the proof of work blockchain right now will have to move their contracts over to the new blockchain and tell their users about it somehow, preferably in a way that the users don't even recognize that they're using a new blockchain. So just like you don't know that you're using a GraphQL database, MySQL, and PHP and whatever on Facebook behind the scenes, the aim is not to let people know that they're using the blockchain behind the scenes when they're using a dApp that's useful and that works very smoothly. And of course, the rent proposal is getting moved over into 2.0 as well. So the growth of the state will be restricted from the start. So people who are building smart contracts for a new system will have to keep in mind the priority of their transactions from the get-go. They will have to consider which transactions they want included and which they're fine with skipping. So now there's this problem in Bitcoin with client diversity. The 95% of the pie chart, that's one single app. Developers of that one single app are all paid by one single company. So one handful of people has full control over an entire blockchain because they dictate what goes into this software that's running the chain. This has been like this for a very long time. And this is something that's been unacceptable for Ethereum from the start, because this leads to extreme centralization of decisions. And it's super, super, super difficult to make it like upgradable. So in Ethereum right now, the 2.0 version is being built by 9 different teams, sorry. So there's ChainSafe, which is building a client in JavaScript, Pegasus, Harmony, Parity, Prismatic, Sigma Prime, Status, that's us, Nimbus, and the Ethereum Foundation itself is building a Python client, which is never going to work in production because Python is too slow for this. But it's a good reference client on which people can base their own clients. And now recently there's also ETH in Swift. All of these clients are working side by side and working on testnets that collaborate. And actually we at Status launched the first public Ethereum 2.0 testnet at the beginning of April. And people are able to join and simulate being a validator. And you can try that out right now. If you go to Status's website for Nimbus, there are instructions to join our testnet, and it works just fine. You can pretend to be staking. So what about the layer 2 solutions like Plasma that we've used yesterday at the party, or Raiden, Lightning Networks, and so on? These are all still very much an option, but they're not required to scale Ethereum on layer 1. So the layer 1 scaling will happen with sharding, will happen with staking, and so on. And the layer 2 will only further increase the throughput to whatever we want. So then it's about the builders to build something on top of all of that scalability. So where are we now? We had this testnet launched. Right now we're building the lib peer-to-peer protocol for cross-node communication. We're working on cross-client testnets, and we're begging for money because it's very hard to get funding for Ethereum clients. One of the most recent grants was the Vitalik YOLO grant, where he just on Twitter started sending out 1,000 Ether to various client developer teams. And I think 7 out of 9 teams got 1,000 Ether from Vitalik just like that. We are planning to launch Phase 0 completely live. Phase 0 is the staking program, which is going to be kind of beta-ish, but early adopters which come and stake in this new network will have increased rate of returns. So your profits will be much bigger than later on. But it's also going to carry a little bit of a risk because it's all very new. But at DEF CON in Tokyo, we're probably going to launch this. I hope we're going to launch this. We're on a good path there. So to keep in mind, Ethereum 1.0 is beta. It's always been beta. It's always been an experiment. Ethereum 2.0 is actually Ethereum 1.0. And that's when we're actually moving into the mainstream with the blockchain. That's it. If you have any questions, I'll take them now. Thank you. Yeah.
Yeah, about beacon nodes, are they paid for that? Like,
no. There is no incentive program for beacon nodes right now, but it's something that's being considered. I've been bothering the Ethereum Foundation and the core teams about this a lot. There's an outstanding issue in the specs repo about that. And I'm not giving up on finding incentives for this, because if we don't incentivize this, we're going to end up with a new Infura, where some big company is going to host a beacon node for everybody. And if that goes down, then everything goes down, just like with Infura right now. Yes?
Which performance do you expect?
Like in transactions per second, you mean? There is no upper limit. Because shards will be able to have their own shards, so you can nest the performance as much as you want. Phase 4 is going to have this quadratic sharding, where you just get shards on shards and shards, and you can just then prioritize how deep you want to go. So there's no really upper limit. It's going to be something in the range of 10,000 transactions per second easily once all the phases are launched. Once the optimizations are applied, it's going to go above that, but nobody really knows yet. We'll see how the clients perform. We see how the networks will upgrade across the world, how latency will tolerate things, what kind of schemes we'll find for encrypting the signatures and validating them, and so on. So it depends. Yeah?
As for the sharding, how exactly would the network be divided? Is there a smart way to do such thing? Or
no, this is still in research phase. There's no smart way to do this. It's not going to be contextual, so it's not going to be like this shard is just for gains, this shard is just for that. It's going to be more like random, but it's not exactly known yet, because that's not the phase that's been completed in the research. So right now we're focusing on the beacon chain and on making the clients work together so that staking can work, and so that when the chain forks, the forks get resolved quickly and efficiently, and that there's no orphan blocks and orphan chains. So once that's properly resolved, then the sharding will come into play.
And that's it for the time.
That's it. Thank you.